All right, so let's talk about this one, Unpacking. And this comes, by the way, from this book called Practical Malware Analysis, which is right here. I had to make this window bigger. This is a very famous book, one of the Bibles in this industry. The problem is it's kind of out of date. The code was written for Windows XP, so I had to modify some of the code to make it run on modern versions of Windows. But this one is going to use some of the programs from the original book that still work. So we're going to analyze some fake malware. This book comes with a lot of fake malware samples, and this is why you want to use a virtual machine. This stuff is not real malware that will spread to other machines and do a lot of harm, but it uses techniques from malware, and sometimes it changes registry keys and automatically pops up every time you restart the machine, and otherwise is kind of irritating. So you don't really want to run these simulated malware samples on a real Windows machine that you like and use. They should be run in a virtual machine, and that's basic hygiene for all malware analysis. You always work in a virtual environment that you can just throw away and restore back to its clean state at any time, because obviously the malware is dangerous. And by the way, I should mention, this entire process horrified me. When I learned this, it was from the European Anti-Malware Alliance or something. I took a workshop. What we're doing here is kind of insane. We're going to run malware on a machine, and we're going to run analysis tools on the infected machine and learn about it from those tools. And obviously, that's an imperfect, risky process. The malware might modify the infected machine so the tools no longer work. And that can happen. But just like in law enforcement, you try the simplest thing, and you only try more difficult things when you have to. Most malware is not that evasive, and you can, in fact, run an analysis machine on the same machine you're deliberately infecting. This is the process called dynamic analysis, and it works, so you try it. I might as well mention, for orientation, there are 4 kinds of malware analysis. There is basic static analysis, where you take the program without running it and analyze it by sending it up, running an antivirus program on it, or Googling it, or going to VirusTotal. VirusTotal is a website that just will recognize files. You can upload the file or put a hash of the file, and it will tell you if that file is detected as a malicious file. That's basic static analysis. You don't run it, and you see if somebody else has already analyzed it for you. And running strings on it counts as that. Then there's basic dynamic analysis, where you run the malware in a virtual environment and see what it does by running analysis tools on it. Then there's advanced static analysis, which is the most difficult of all, where you disassemble the malware and try to read all the assembly code to figure out what it does. And then there's advanced dynamic analysis, where you run the malware in a debugger so you can stop and start and change the running of it, and that's easier. Anyway, what we're doing here is a little bit of unpacking and static analysis. So we're going to use this malware sample, Labo 102, with bin text. Let me shove my instructions out of the way, and I can do it here. All right, so the malware samples from the book are already here in this folder called Practical Malware Analysis. And by the way, they will set off your antivirus, which is another reason why you need a virtual machine with no antivirus installed to do this work when you download these, or your antivirus will erase a bunch of them. So we're going to examine the strings in this. Now there's a command line tool, strings, that shows you the strings, but there's a cool, handier tool from McAfee called bin text that is just a nice graphical way to observe the strings in a file. So I run bin text, and I might as well maximize it. And in fact, I think there might be a way to make the font bigger, but let's try opening this file. Browse, desktop, labs, binary collection, chapter 1, and I want lab0102.exe. All right. Now I'm only examining the strings in this file, so you might feel like it's safe even if you don't want to run it, but this is an important thing. Running any kind of tool on a malware file might run it, even if that's not obvious. That's why you always want to be in a virtual environment when you're running any kind of programs. Now here's the strings in that file. I would like to make them bigger, and I believe there is some way to do that. It might take me a minute to find it. Search, filter. I think somewhere there is a way to make the font bigger in this program, but maybe not. Looks like I'm not able to find it. All right, anyway, this is showing the same kind of strings we saw before, but you might notice here there's something called malservice. And here's something that looks like a fragment of a URL, HTTPW, and here's part of a URL. So what's happening is the strings in this file are sort of broken up. And there's a reason for that. There's only a few strings, far fewer than we saw in the last bit when we were looking in Process Explorer, and that's because this is a packed file. And we can tell that by using the utility called PEID, which is also installed on here. PEID tries to identify what language a program is written in. So if I open that file here, which was Chapter 1, Labo 102, okay, here it tells you that this is, the sections are named UPX0, UPX1, and UPX2. And it didn't find a language, but it found that the name here is UPX. And let me compare this to a normal file. If I launch another instance of PEID, and I look at that 99.exe that we just created with Visual Studio, guess I can only run one of these at a time, but that's all right. C99. Here's the one we made. This thing we created, and it is, the normal sections are called text, RData, data, and relocation. Those are the normal names you'll find. Having names UPX0, UPX1, and UPX2 is a dead giveaway that this is a packed file. Packed files are like self-extracting zip archives for executables. You can run them, and they unpack into RAM, so they put the right program in RAM, but they scramble what's on the disk to try to confuse analysts and your malware and your antivirus product. So that's what this is. This is packed with the UPX packer. And we can see that with another tool called PEView, which lets you see what these files are made of. PE is portable executable. It is the name of all Windows software. All Windows software is in the category of portable executable. EXE files, DILs for libraries, and .coms, another kind of executable. So if I go to my desktop, Malware Analysis Labs, Binary Collection, Chapter 1, Labo 102. Okay, here is the breakdown of this file. Here you see the entire file in hex and ASCII. Every Windows executable file starts with MZ, that's the mark, and then it has this useless stub from the MS-DOS days telling you about MS-DOS mode. And then it has, here's the section headers, UPX0, UPX1, and UPX2, and down here are the sections of data with things in here like some libraries. Here's the name of some Windows libraries, kernel32.dil, advanced API 32.dil. These are the Windows API libraries that are brought in. Here's the specific functions that are used from those libraries. And this is the very small set of functions used by the packer. So you see here there are various headers. One thing that's useful to know is there's a header here that tells you the time when the file, this one here, you can get a date timestamp when this thing was compiled. And this is what a lot of people use to try to guess what country made this attack. They look at what time of day it was done and whether that's normal working hours in like Asia or Russia or America. That's one clue. And by the way, it's not reliable. Some compilers don't put this timestamp correctly, and you can modify it, but it's one indicator. It helps you attribute files. And down here's the headers that tell you the size of the various sections, and down here are the various sections of the file. All right. And there's an import directory table here in UPX2. This is where it imports functions from libraries. You can see from the kernel32.dil, here's the 4 Windows libraries it uses for internet functions, WinINet, and advanced API functions here, and almost everything uses kernel32. The kernel is the heart of the operating system, and almost every program you use uses that. So that's another way to see what's in your file. And there's another program called CFF Explorer that lets you see what's inside Windows executables. So if I open that thing, which is on desktop, Malware Labs Binary, Chapter 1, lab 0102. All right. And so now here, here's the import directory here, and here's kernel 32. If I click on that, down here it tells me exactly which libraries it's using. Load library, get process address, virtual protect, virtual alloc, which is used to allocate memory regions. So here you can see exactly what libraries, what functions are used out of each library. And we saw this information in strings too. So now we're going to unpack this thing with UPX. We should already have UPX. If I just open a command prompt, like this one should work. If I type UPX, it should be installed on this machine already, and it is. This is a ultimate packer for executables. It's an open source packer that people use. And so we can unpack this thing, but we have to get to the directory where it is, which is kind of annoying. It's in users, and then your login name, which is student, and then practical malware analysis labs, desktop rather. And my students that aren't good with the command prompt find this pretty demanding. And then I think it's binary. I'm just going to stop here and do a directory. Binary collection. All right. And now it's chapter 1. Hitting a lot of tabs, it'll go through the list. There it was. All right, chapter 1L. And now if I do a directory, there it is, lab 0102. Now I can unpack it here. When what you do is you use UPX, and the help message tells you how to do it. UPX -D will decompress the folder, and it's -O to tell it where to put it, -O file. So it's UPX -D, and the thing to unpack is lab 0102.exe, and then I want to put the output in lab 0102 unpacked .exe. That should do it. All right, and now if I do a directory, I can see that the original packed executable was only 3 kilobytes. The unpacked executable is 16 kilobytes. And now, if I examine the unpacked file with PE view, it will look different, of course. So PE view, the unpacked file now has text, RData, and data. Those are the normal sections, which are very different than the sections we saw before that were just UPX0, UPX1, and UPX2. And it looks different in CFF Explorer 2. And also, it'll have a lot more strings. If I look at the strings with bin text, if I look at the unpacked file, I'll find a lot more strings. So that's here, the unpacked one, and go. And now I have more strings, and I have readable things here like Internet Explorer 8 and a URL and some names of some services and such. So there are some hidden strings that were missing or broken up into little chunks in the packed version that are now visible. So that's this PMA 102 lab, and you should try doing some of that. I'll stop this recording.